Alright guys, so for question 6 we'll do this one here, the 2019 question. So just give a quick read first. Lads, if there's one question you want to read, it's this one anyway. Just make sure that you understand exactly what you need to do. So, the figure shows a design for a rugby trophy. The curve ABCD is parabola, so that there is a parabola. Right? The vertex is at B, so the vertex parabola is there. The curve DEF is identical to the portion of the same parabola with vertex E. So DEF is identical to this one, so we're probably going to have to translate that though. We'll get to that though. So this curve is identical to that. The curve JKLM is an ellipse with focal points at N and P. So that is an ellipse, they are focal points. The line BT is a tangent to the ellipse at point T. Draw the given design showing clearly all constructions and points of contact. Alright, great. Right, so two options here to start off. You can start off the ball or the base. The handiest thing is to start off the base. If you're going to do, if there's something on an angle or it looks like there's two separate portions, just go through it in your own head. Say, geez, if I did that, if I can get B, right, I can go up at 60 degrees, 30, so I can start that. Just make sure you'll be able to start the second part. Just quickly go through what you'll be able to do in your head, because sometimes the odd time it comes up where you could do the question and it turns out that you have to start with this. You know what I mean? So just make sure that you're starting. If you're starting on a point, you're able to finish on a part, you're able to finish it. All right, so I'll just draw the base here along my. Let's fill in this actually. Question 6. What did I say? 2019. And we'll put it in as ellipse slash parabola. 1905, right. Okay, 2020. Okay, great. Right, so I'll come down. I'll come down. I won't be going any lower than what I have down here anyway, so I can start nice and low on the page. So I'm going to come down here. I can zoom out here actually, just so we can see where I'm at. Okay, so this parabola anyway, I can start off with that. It says the vertex is at 80, so that means the entire width of that parabola is going to be 160, isn't it? So I come over 80 and then another 80 over here, and of course when I'm drawing a parabola I draw the rectangle the thing goes into first, and the size of that rectangle, the height of it is 40. Now draw that across and then I'll draw that. So there's my rectangle that the parabola is going into there. Alright, remember, if you're drawing a parabola you only draw half of it first. So I'm going to concentrate on drawing half the parabola in there, okay? So will I label B? Where's my pen? So I'll label that's B, which is actually V, the vertex, so I'll put that in there. Will I label it? Oh, I'll put it up here. I think that should be okay. Right, so there's B, and down the bottom corner is A. Right, so when you're drawing half the parabola, you have to divide both sides of the rectangle into equal parts. So I have a 40 here and I have an 80 here. So I'm going to save myself a lot of hassle there now by just dividing it into 4 on both sides. Besides going, so I divide that side into 4 and divide this side into 4. Now, this is one of the only questions I've ever seen where both sides divide evenly into the same number. So I'm going to take advantage of it. So I've divided this side into 4, that side into 4, and of course I'll draw my vertical lines in line with the line of symmetry of the parabola, or the line that splits it down the middle. So that one there is going through B, so I split it that direction. So there we go. Okay. There we go, and I'll label it. So remember, V is here, and then I label it 1, 2, 3, skip the corner, 1, 2, 3, and I join B to 1, that, B to 2, B in this case, that, 3, like that. And where B to 1 crosses 1 is a point. Where B to 2 crosses 2, that's a point. B to 3 crosses 3, that's a point. And I'll use axial symmetry through the center of symmetry on that parabola to find the points at the opposite side. So I'll just extend them out, and I'll use my compass to get them at the opposite side. Like that. That. The opposite side. Right, so there's all the points at the other side, and now I'm going to do a little very, very light line down through the top. And then one H line. And there's my parabola. Alright. Okay, then after that, it says I may as well do this translation down here as a method. So it says that this is the portion below is an identical portion, so I'm going to use translation to bring them all down. B to E is 20 millimeters, so there's 20 millimeters there, and I mark down 20 millimeters, so there's 20 millimeters there, so there's E, so that's the top of the second portion down there. So that means I need to bring all the points down 20. Now where does it stop here? Well, I'll bring it more than I need. I'll bring more than the curve that I need, and it should cross through that line, giving me the part where it cuts off. So I'll show you what I mean there. So I'll bring down 1 goes down 20. So this, I'll actually bring down all them points there. So I have a point here. So that's gone down 20. Everything is gone down 20. 20. 20. I don't think I need the very end points on that. Okay, so I get 20 on my compass. So the distance from BT, my compass, there's that gone down the distance I need. That's gone down the distance, that's down 20. That's down 20, you can see there it goes below the line. This point goes down 20. This point goes down 20. This point goes down 20, right. So I go on my, of the point to the second curve there. So I'll draw it in 2H first, just to get where they cut off. So that there is where that point there and that point there are where they cut below the line, and that gives me D and F. So now I have D and F, and I'll finish off the curve 1H line, starting above the line it told me. Nice handy tip, lads. If you're drawing a line like that, always look at the part you want to go to. So if I'm going from here to here, I'm actually looking at this. I'm not looking up here. That's where it starts to get wiggly. So look at where you're drawing the line to. Generally work out for you. Alright, and then so now I have the kind of base of that trophy down there. Grand. So there's my parabola and my translation of, or the identical portion of the parabola below it. Okay, after that, to go up a distance of 30, here we go here. So there's a line going up at 30, and I'll draw that for out there, so I know that this line kind of standing up the ball. So to get J, I have to go up from B up to J at 60 degrees, and that there gives me J. The other side doesn't tell me what the story is on the other side, but this gives me J, and J is the start of the major axis of this ellipse. So I'll draw the major axis there like that. Do we have a distance for it? I do. It tells me that the major axis is, half the major axis is 85. So there it is there. There's half the major axis. And if half of it is 85, then the full lot of it is 17, or 170. It's 285 is 170. So there is my half major axis. That's the full major axis. Jeez, I hope it fits in now. And I'll draw them where the minor axis would be if I want to put it in there. And it also told me where the focal points were. So it says here the focal point is out 70 out here. So there's the focal point, 70, and if it's 70 out there, then it's 70 out here. There it's there. And I've actually labels for them. That's going to be N and P. Normally we call them F and F1, but they're N and P in this case. And I'll just label this for now. A. Right. Okay, so I have a major axis, I have two focal points, I have where the minor axis should be, but I don't have the minor axis. So how do I get the minor axis? Well, if I didn't have the focal points, I'd go from the top of the minor axis, I get half the distance of the major axis of my compass and swing that from the top of the minor axis, so it'll work the opposite way around as well. So if I get half the distance of half the major axis, and swing it this time from the focal points, well, where it crosses through here is the top of the minor axis. Because if I did it the other way around, it would work that way. Alright, so I'll do, so now I have my major axis. Just later in there. Just so you can see clearly there. You are still doing 2H. I'm just going to put in a light red line. Okay, so I have my major and minor axis. So I'm away. All I need to do is get rid of here. Alright, this one I'm going to do. So a bit of paper here. And let's start on my setting up my trammel. Okay, so C to 1. C center 1 is half the major axis, and then C to 2 is here. There we go. Right. There's my trammel. Right, remember, 1 stays on the minor axis, 2 stays on the major axis. Okay, C is a point. So let's kick off. So 1 stays in the minor axis, 2 on the major, C is a point. C is a point. C is a point. Now you can put as many or as little points as you like, just as long as you get an accurate curve. There's C is a point. 1 stays in the minor, 2 stays in the major. C is a point, and we stay on the page, just above, C is a point, 1 stays in the minor, 2 stays in the major, C is a point, keep going, 2 stays in the major, 1 stays on the minor, C is a point, major, C is a point, C is a point. C is a point. 1 stays in the minor, 2 stays in the major, C is a point. 1 stays in the minor, 2 stays in the major, C is a point. Stays in the minor, 2 stays in the major, C is a point. And we do one last one down here. That should be right there. Right. Now, if all my points come around, so I'll draw a nice little like that going around. Light as I possibly can. Okay, and then my H pencil will go 1. So there's our ellipse in there. Oh jeez, it's outside the camera. Alright, so there's our ellipse in there. After that, we have this tangent to get, right? So point T. So we have to get a tangent from B onto the circle. So a tangent from a point outside the ellipse is the one that is difficult enough to remember. So take the distance of the full major axis. Jesus, what do we have to get on this now? The full major axis, hopefully it reaches just about the full major axis, like that. And you swing the distance of the full, so there's 2 focal points. This is the one that kind of is related to nothing, you just have to remember it. You have the full major axis, you take this full major axis and swing that from the focal point furthest away from the point. There it is there, so I'll swing that like that. Okay, and then from the other focal point, you put the point of your compass on the point that you want to go from a tangent from, and you join that. You take the distance to the other focal point, and you swing that arc from there through this one, through the one you did a while ago. So the distance from there to there. And then where the two of them cross through each other, you join that back to the first focal point, the one furthest away, like that. And when that crosses through your ellipse, that is your point of contact. There. So that there is my point of contact. I'll join E onto that. Okay. And all I have to do is put these little teeth in the middle, or the laces in the middle. I have to go 15 either side, do I? So it goes 15, yeah, it's 15, so 15 this way, 15 this way. I got 60 degrees like that. There's 15 that way. There's 15 that way. And then have to join this back in. Now you can see that they are 2H lines. So this is staying as a 2H. All that's going to be visible or all that should be visible with a H line or a working line is the actual laces themselves. Okay. Alright, and then there's 1 in the middle and 2 either side. So I'll put the 30 in the middle, and I'll go 15 this way, and I'll go 15 this way. And I'll draw my laces so they extend until they hit the top and bottom of that diamond. Top and bottom of the diamond. There's my 15. There's my 15. Right. That is our question done, lads. So, look, the parabola and the translation, it comes up quite a bit like an identical curve. You just have to figure out, right, what 2 points in the curve. I had the vertex of the first curve and the second one, so that gave me the kind of guide for my translation. It was that direction, that distance, so I did for all of them. The ellipse, that's the one that comes up commonly. You're given the full major axis with the 2 focal points. Remember, if you were given the focal points, you go that way, you can reverse it as well to get the top of a minor axis. And the tangent outside, that is a difficult little one now, lads. The tangent to an ellipse for a point outside is a tough, it's kind of, I can't explain it that it relates to anything. You have to just get the full major axis from the focal point furthest away, swing that arc, and then from the point that you want to get the tangent from, go to the other focal point, the closest one, and swing that through it, join it back to the first one, you get your point of contact. You just have to know that. Can you get that done? That's the last one, that's the 6th one. So can you get that done, please?